All right, everyone. Welcome back. Welcome back. Quick little break, but we want to roll right back into it. This is our last talk of the day. So after this, please make your way over to the villages, have some fun, pick handcuffs. I'll show you how to do it with a rubber band if necessary, but also have an opportunity to ask some questions, get some answers from these folks and from other speakers of the day. Also, come find me if you want to talk bug bounty and the new AI bounty program. I'm going to keep saying that because I want you guys to invest in it. So next, our next two speakers, Chris Bukavich and Emily Yale. They'll be talking about unmasking Azure-based adversaries. All right, have fun.
Good afternoon, guys. And so I'm from the Hunt team here at Microsoft. We handle a lot of different security incidents here. We work on detections, and I work on a little bit of our automation framework of how we basically connect together everything that's a massive environment of over 200,000 users at Microsoft. So, and Emily Yale here is from our data science team.
Hi, yeah, I'm Emily. I'm on the detection analytics team as a data scientist. So I help protect Microsoft internally whenever we identify a gap with a first-party detection or anything like that. Chris comes to me with a problem and he says, Emily, solve it. That's kind of my job.
Cool. And so one of the big things that's been on the rise here at Microsoft, and this has always been a thing, but we're going to be talking about a little bit today of the evolution of service principals and what that kind of means in Azure, and how do we actually respond to that and detect abuse basically happening with these service principals. So we'll start out with a little bit of an introduction of what they actually are, and I'll kind of explain how they've changed over the years. So with service principals in the past, you may have had local AD accounts, users, maybe they were Linux accounts that were local, and just kind of everything else. Today, with Azure, we've went to kind of service principals. And these service principals, they're very unique from the way that you had service accounts in the past. So with a service principal, they're basically local instances of an app registration that you may have. So these app registrations may be in other environments. And this is a local instance of the service principal. And so a service principal can use creds with them. So you could have basically a client secret, which looks like a password. You can have certs based with them. And those certs could be self-signed, or they could be from an issuer. So with that, you can do a little bit. So in the past, we were using credentials with service accounts. But one of the newer things that came on the scene was managed identities. And with a managed identity, you can basically take the threat of leaking those creds now so that you don't have a cred in your environment. So with that, now you have a user-signed managed identity, which if you go to your Azure sub, you'll see basically one of those, you'll see an object that's in your sub of that user-signed managed identity. That user-assigned managed identity could be mapped to multiple different resources that are in your sub. So with a system-assigned managed identity, that's tied to one resource. And this is kind of important to note because we've went in the past from basically using certs and passwords, now all the way down the line to not using any passwords. But service principals, they have a little bit different controls around them. And so you can kind of see here a little bit of how a service principal kind of gets made. So in your home tenant, you'll have your app registration. And so that's kind of your global object. Then over in a peer tenant, you can have that service principal that gets made off of that app registration. Now in your tenant, you can have that app registration as well. That's off of that app registration. And that app registration, again, is a blueprint. So it's basically the building blocks of your service principal. So we were talking, though, you can use the service principal as basically a service account to go do different automation tasks in your environment. But one of the other things that a service principal does is it's basically used for authorization and authentication into the application. So if you have MD, Sentinel, a lot of these different things, you will be adding that enterprise app or the service principal to your tenant. And this is a little bit important to know because if you look into Azure Portal, you'll see a number of different enterprise apps. And you'll say, oh, OK, I have 3 different enterprise apps in my brand new tenant that you may have made. But behind the scenes, if you actually look, you have dozens and dozens of different service principals that are in your environment. These are tied to different resources like MD, Sentinel, storage blobs, all these different other things that are out there. And basically, these can be used for authentication again, or they can be used as a service account. And so they can have this kind of dual purpose to them where you can go access Azure resources with them, like your VMs or your key vaults. And so I'm going to kind of show you a little bit through here of our demo app that we've made. And so you could see we have a couple different things to this app registration. So we have our API permissions. So these are scope permissions that you're developing for your app that are either delegated or they're going to be app permissions. So in your app, if you're going to be delegating that permission, basically the user signs into your enterprise app here, that service principal, and then they will get the permissions that are defined in the scope here of the API permissions. And those will trickle down to that user when they get the token. So that user, effectively, whatever they had, you're elevating their permissions. Then you can also have that service principal, that app, and define your own API and have custom roles to that as well. So if you want to add, say, a admin privilege that's read-write-all for your app, you're making like a database, you want people to interact with that, you could say you have read and you have write. So you can define that. Your manifest is a little bit more of your blueprint. So you can go kind of look at a little bit of wider picture in a JSON format, what that blueprint looks like. You can see really clearly there's client secrets and the client credentials there. You can see there's one certificate that's there. And so if you're remediating this, you can just go click in there and you can go look at it. But we'll actually talk about this is at the app level. You don't see anything in the Azure portal for what's at the service principal. So again, this is the blueprint. But what if in your tenant, you have assigned to the service principal itself a client secret? You will not see that here. You have to use the Azure CLI or Graph to go see that. So you could actually see where that service principal is listed in your environment as that managed application. And so again, we're going to go over a little bit here more for incident response. You can go into a little bit more here too with the redirect URLs about authentication, and that would be basically one of the pieces when a user signs into your app, or there might be a local host for native ones. But we're going to be talking about really here for the incident response. And those are the key things that you want to know. And so when you're threat modeling this, you might be like, all right, cool, I got that. There's the app registration here, the enterprise apps in my tenant. But that isn't the whole story. You saw API scopes and you saw some other things there. But there's a little bit more to understand. That service principal is an object in Azure. So in your Active Directory, or Intro now, it could also have Active Directory roles. I can go assign global admin to my service principal. But I could also assign API roles that are equivalent to that role. So you can kind of see in the graph down there, it breaks it out into 3 different pieces. Azure resources you'll have access to, we want to map, app permissions, and your Active Directory roles. And off of that, you have your delegated permissions again, and then also your permissions that are going to be to the app itself. So if we're looking at, what the scope of what can I do against this, not all these different service account types have the same permissions or what you can do to control them basically are. So you may be like, hey, in the past for my user accounts, I could add conditional access to here. I can do multi-factor. Not exactly the case with service principals. There's a couple limited controls that you can do, like you can restrict IPs, what you can do with it, But there's a lot of, there's service principals operate a little differently than other models. So every single one of these have to be handled differently in your environment. Now, we're kind of talking here a little bit more on how you can go find if your service principal actually is a global admin in your environment. And so the answer to everything is almost always Graph. Graph has almost everything that you may want here. And so we could see I queried for my service principal, and I found, hey, the display name says global admin. One of the other things is you'll see that ID that's blurred out there. That ID, it's not really unique or anything, but that ID, a lot of these different things in Graph, they all map back to an ID of what the role is. So if you were listening to one of the talks at Azure Red Team, and some other folks were talking about with attack maps and attack paths, one of the things that you can do here, and I'll talk about in a second, is you can map these IDs to understand in a graphical sense what something has access to. So the second thing that we're going to kind of talk about is the API permissions that this has. So this was, again, back on that initial page. We were talking about the API permissions that it's going to have kind of at the app layer. So these are broken down into user consent and admin consent. So you'll kind of see on the right there, I have my app, and I'm going to be making and adding a different role or scope. And I could say, who can actually approve that? Is it going to be admin or users? And then I could go see, once those scopes and those API permissions are added to my app, I can go use Graph again to go look up that service principal. And I could define actually what the app is that it's coming off of. So if I wanted to look up that service principal in my environment that comes from Active Directory, which I believe I was searching here, so you could see, hey, here's a list of some of the different roles that can come off of that. And then what I did in my environment is I used Network X to basically load all this data that we've already been collecting into just graphical form. And so with Network X, you can go build on top of that to add different things, like your user perms now on top of that to go show it. And this is all the code that I've actually used. It's only a couple lines, but it's far easier to use something like Neo4j or a graph database to go do a lot of these, because the interfacing and the pipeline is a little bit difficult to set up. But you can do this manually on the fly if you need to as well. So to kind of understand what the Azure resources this has access to is much harder. So the other roles, the API scopes and the Entra permissions, those are pretty easy. I can go to Graph and I can go search through there. But one of the things with the Azure resources, you need a role on every single subscription in your tenant that might be at a reader level, or you may need to be GA and flip a switch in Entra to basically allow you to manage every single subscription in the tenant. It's a pretty dangerous role, so usually when we're kind of going through this, we usually reach out to the owners in incident response and basically get asked to get added to your subscription. There's a lot less risk in that. You can also look up some of these permissions if you get added to that subscription without going through Azure CLI, just in the GUI through the AIM. But you can use Azure CLI to do AZ role assignment list, and then for the assignee, and then you'll get back a nice list of all the different things it may have access to. But again, this is limited only by the account that you're querying if it could see that subscription. So if your account can't see those subscriptions that it has access to, you won't see it. You can also use the graph management API, or the graph there. There's API Explorer. That's a playground. It's basically like the Graph Explorer, but it's in Azure. And so you can go tweak a couple of these things, and there's a token already set up for you. And the last thing for Azure Resource is you could actually just see it in your logs a lot of times. In Cloud App Events, it literally tells me, hey, this guy was a contributor on this sub. So that's pretty cool. Like, I don't even have to go through the hassle of going through all this if I've already seen in my Cloud App logs that it's a contributor. So when we start the investigation, there's a couple logs here that we want to kind of look at. We're going to want to know, basically at a high level, where did it sign in from? We're going to want to take a look then at some of the alerts to kind of start our investigation and understand like what might have happened here. And then we're going to look at a little bit of the audit log to see, okay, what are the things that may have happened to the service principal that are more notable that may have changed in some of the permissions and everything it has. There's some other logs here too that are very notable, like ADIP. ADIP will tell you a lot of really cool things, like if a credential has leaked for your service principal, it will actually go hash that credential and validate it against Active Directory to go see if that's valid. And it'll send you an alert with ADIP. There's other alerts that are under there too, so we lean heavily on those here at Microsoft to kind of tell, hey, like if something's been leaked. Cloud App Events will go tell you your Azure resources that this may have accessed, so it'll say, hey, this service principals went out to a storage container or your key vault. So you can see a little bit more of that. Your app insights and a little bit more custom app logging will tell you what has actually happened in the app. So you won't see that really anywhere else. So you have to kind of do some additional logging there with app insights or some custom inline app logging. And then there's another table that's just called Azure Activity and Sentinel. And this is a little bit more general other logs. So we'll kind of start here with our scenario that a client secret has leaked of our service principal. So we're going to ask, did the actor use that yet? Where was it used? What Azure resources were accessed? And what happened? So we can see here in the sign-in logs that I was talking about that service principal. And one of the things in there is a service principal credential key. If you go look in your app registration and you go look at that, you'll see the credentials and you'll actually see a thumbprint for your certificate or your client secret. So you can tell exactly if you have multiple secrets in there, which one has leaked. And then off of that, you can go search. So it helps speed up your investigation a little bit more. From here, we're looking at some of the login events. And I can see at the bottom that 7000215, that's kind of talking to that the client secret was invalid. And so someone was trying a couple different client secrets against us to go sign in to Graph. The next thing that they did is we could see 0, so that's successful. And then they end up going to Azure Key Vault up the line. They sign into a custom app reg, and yes, service principals can go sign into other apps as well. The last thing that it does is it tries another app reg, but that code at the top says you don't have a role on this other app. So that's also another notable one. That might be enumerating through apps that it doesn't have access to. It's something we often see. So now I'm going to go take a look at my audit logs to go look at that service principal. And gosh, there's a lot of things that happen to this service principal. There's a couple admin consents that were added to this. So there's a couple role assignments. Behind the scenes, I dug into the logs, and our service principal is now global admin of our entire org. That's kind of weird. So the next thing I'll do is I'll check the API perms to basically go tell, okay, if there was users that were signing into this, what permissions were they getting? And what app permissions does that service principal itself have? And you could actually see, I was talking about admin consent, is it actually granted? So anybody can go request a permission, but it's only granted once the admin of your tenant has added it, and you'll see that as not granted to your tenant. So the one below it is granted. So if I want to take a look now at the Azure resources, so I've kind of scoped down, I have an IP address that's our attacker. I've seen that the service principal has elevated perms, so now it's global admin, and it has some other API permissions that were added to it recently. The next thing that I'm going to look at is what Azure resources has this looked at. Again, one of the things to go look at the Azure resources is you need to be global admin with the elevated perm, or you need to look at a little bit of different scenario to go looking at your Azure resources. Maybe that's some sort of lower reader level that's across your resources. You can go look again at the AIM portal, or you can use Azure CLI with AZ role assignment list, and then the assignee object ID. Use the Graph Explorer, and you can see it in your Cloud App Events. So in your Cloud App Events, you'll actually see, and these are really cool logs that were just recently added. So this is kind of like a hodgepodge of a lot of stuff. So in your Cloud App Events, you can see user activity, but you can also see a lot of activity that happens in Azure itself. And so that application field that says M360, you'll see something like Azure, if it's an Azure application that it's going out to. But again, I could see a lot of what happened in my audit log right over here. So I could see that there was consent to the application, there was a new role that was added to it, and I could go see what roles were added to it once I look into that. Here, you'll also see a lot more, again, basically Azure resources that were being accessed. And this is an exact query that I could use to go look up those Azure operations here. And so I'm looking underneath my subscriptions, what operations happened here. And this is a common thing that I'll do kind of with sign-in logs or anything else. I'll kind of baseline what is normal versus not normal. So I'll bin up a lot of the logs here, and I'm just looking by what the operation type might be. So maybe it's like updating the key vault, reading from it, listing it. And I could see here, like, hey, this service principal looks like it's been dormant for a pretty long time. And then tomorrow, it's had a lot of operations in Azure here. So it looks kind of unusual. I'll do this with the sign-in error codes too. So I'll kind of look at a baseline of what might be the weird sign-in error codes. And then I'll kind of see, like, is there a jump in those over time? So the remediation of these is a little bit different, again, across all the different. So your regular AD service account or your service principal, you'll have to revoke the credentials. On an AD service account, you'll have to revoke those sessions as well if it's like a user. In Azure Service Principal, you want to go disable the sign-ins, and that's on the Enterprise app. You'll see a sign on there, let's say disable for user sign-ins. And you'll want to revoke the credentials and the certificates from that portal or from the Azure CLI if they're assigned to that service principal itself. With the managed identity, which is pretty cool, you do not need to do anything, basically. You just need to evict the actor from whatever it got access to. Once that's done, the tokens are short-lived on that managed identity, so you don't really have to do a whole lot. And so you might be asking again, gosh, there's a lot of problems. What can I do to kind of like start limiting this access? So just consider restructuring a little bit more of like, and thinking about how service principals are approved and permissions are assigned in your environment. You'll want to start assigning access to resources first. We see too often accesses are assigned at too high of a level, like a subscription. Or they might have a high level of permission like owner or contributor. Owner and contributor can do pretty much everything that you want in your subscription. And again, limit high level permissions that may need that admin consent. One of the cool things I didn't add to the deck here recently was that you can actually, on those custom app scopes that you add, those roles that you add, you can actually start assigning now with a new feature that has been added, what risk level they might be for your custom ones, which is pretty cool. And again, you're going to want to look at the documentation. And the documentation for app role assignment read all, it's highlighted in red on the documentation page once you look up what that is. So your admin, when you're giving consent, read up the documentation what it does first. It can be kind of unclear with a lot of things, but if you read the docs, you can understand a little bit of the scope of what it's doing. And again, set up different apps for different scenarios. We see too often apps and service principals will be assigned all of the permissions in the world. So if you're asking for something that's, hey, a user's going to go sign into this, and maybe they want to elevate their tokens, consider delegated. Now, if it's a service, maybe look at app, but limit those roles for different functions. And sorry, the last thing I was going to say is use Key Vault in a lot of your code. So reference your credentials like that, and try to leverage managed identities a little bit more, because all these things might exist in your environment, and you may need them for different things. You can't use one of these for everything. So using managed identities and a lot of these other things with Key Vault has helped out a lot. I'll be passing it over here to Emily.
All right, thanks, Chris. So now that everyone's an expert on service principals, we know exactly how to remediate them, and in the first place, we're going to set them up perfectly. We're going to talk about this last piece, which, I mean, we don't even need, but just in case, how would we detect malicious behavior from a service principal in our environment? And so I'm going to talk specifically about how we're doing this for Microsoft internally. And so you might imagine I have a little bit of a volume problem because we have like a few of these service principals and they generate like a handful of entries in the logs. So that's going to be issue number one. Second, on the slide here, I have a couple different sample service principals kind of highlighting some aggregate features of what a day of activity might look like for them. And you might notice that they're not very similar to each other. So I also definitely have a variety issue. In particular, for those of you who are looking for more data science terms, I have a long tail problem. So I have a lot of things way at the extreme ends of these different features. And that's going to mean that identifying malicious behavior is going to be difficult. So I'm going to start with the raw data. Chris mentioned the service principal sign-in logs are a great place to start. And so that's what I'm going to use. And that's kind of handy for him when he's investigating. But I want features from that data instead. And so if I want to identify a malicious service principal, well, that's my first natural aggregation level. So, okay, I'm going to look at things at the specific service principal level. And then secondary, if we're trying to capture behavioral elements, I also want to bucket by some sort of time feature. And so we're going to do that by a day. So I'm going to take a day's worth of activity for every unique service principal, and I'm going to aggregate a couple things about what I'm seeing in the sign-in logs that capture behavioral elements that I actually care about. So I want to know how many times did they have a sign-in event, how many of those were successful, how many of those generated some sort of unusual error code, as well as features about where did those sign-ins come from, what were they trying to get to, and those sorts of things. And so now that I have data that's been turned into features, it's going to be easier for me to take a look at how am I going to sort through this service principal data and actually identify the malicious ones. And so one of the things that we notice is that service principals tend to have these clusters or these groups of other service principals who aligned with them on some of the aspects of those features. And so that means now that the hypothesis I can form is that there are these peer groups that exist. And if I want to find a potentially malicious service principal, I want to find one that seems like it should fit into this peer group but is otherwise appearing anomalous in some way. And so given that's my hypothesis, a good detection method for me to try is local outlier factor. And so if you're familiar with other unsupervised anomaly detection methods like isolation forest, those can be global methods. And that's nice if you have this sort of top-level view and you're looking for the ones that stand out when you look at all the data in aggregate. But as I mentioned before, I want to find these pockets that potentially have a service principal that shouldn't really fit into that pocket. And so that makes LOF a better fit for me. It is going to turn up more anomalies as a result because instead of looking at the big picture and saying, okay, you over there don't fit in, you over there don't fit in, I'm going to walk up to all of these different groups and I'm going to say, oh, you don't fit into this group, you don't fit into this group, and you don't fit into this group. But this is going to be a good fit for me. And in order to make this simpler from both a computational perspective and to take advantage of some of these shared features, I'm going to bin my service principals into different groups based on how many sign-ins they attempted that day. So we have our low volume group, we have our medium volume group, and then we have our high volume group. And if you look in aggregate across those features that I mentioned, they tend to be fairly similar. And that's going to be nice because we're going to take advantage of that in the next step. Okay, so if all anomalies were malicious events, I would have actually already been done because I found all of the anomalies in the prior step. But as everyone in this room knows, that is never the case. And specifically because I picked this fine-grained method, I've turned up quite a few anomalies. And so I need to apply something on top of that to filter it down further. And that's where I, as a mathematician, am going to go to a statistical approach. So as I mentioned before, there's some nice features about those bigger groups of service principals that I created. And I want to hone in on some of the ones in particular that we found aligned most closely with incidents of prior malicious behavior. That's the number of resources that were accessed by the service principal and the number of unusual errors. And so again, I have to look at this per group, because if there's a service principal who only had, say, 3 sign-ins, but that attempted 3 different resources, that might still be an anomaly I care about. And I don't want to only consider the service principal that had 1 million sign-ins and accessed 1 million different resources. I want to be able to catch both of those incidents. So for each group, I'm going to determine the statistical outlier value for those 2 features. And I'm going to say, okay, for this service principal in this day of activity, it made it through my first test, so I identified it as an anomaly compared to its peer group, but now it has to also exceed these outlier values for both of these 2 features. And if I can satisfy both of those criteria, now this service principal is going to move on to the next step. Because of course we're still not done. We still have too many results because there are too many users who do weird things and turn up anomalous results all the time. And so what we want to do on top of that is apply this scoring approach. And this is basically just looking at, for each service principal that now made it to this final stage, what proportion of the maximum value of those 2 features that I really care about does it have? And we're going to sum those 2 proportions, and we're going to require that it has to have a value of at least 1 in order to finally get flagged as a result. So this will guarantee that I'm taking, for all of these different groups, the service principal that had the highest, most anomalous value for each of these 2 features. So that's good, I care about that. But it's also going to take along the ones that were fairly close to the highest value in both of those, and it's going to ignore the ones that, while they may have been statistical outliers, they weren't nearly as weird as some of the other service principals that were identified. So now we've truly pushed the most anomalous results up to the top here. And so if you're wondering what this kind of looks like from a volume breakdown, I have the results for September 25th. So on that day, we had like 92,000 active service principals. When we ran that local outlier factor, we turned up 4,000. So already that's kind of like a decent reduction in terms of volume, but that's clearly way too high. So then we applied our statistical testing to look at those 2 features that I really care about. And we got down to 140 results, so that's pretty good. And then we did that scoring on top as well, and we're down to 22. So we've really made pretty good progress going from 92K to 22. But as I mentioned in the intro, you know, Chris is my customer, and if I told him he had to investigate 22 accounts a day, I think he would fire me. So even then, this is still not quite good enough. So one of the log tables that Chris mentioned earlier is something called AAD, Service Principal Risk Events. And so Entra does have a first-party detection that also tries to identify anomalous service principal behavior. But it is not using the same feature set that I'm using on this custom solution that I'm building for Chris and his team. And so what we're doing now is we're looking at the merger of these 2 methods. And so, I mean, generically, this is a good idea, and this is where we're going to get the most value out of these data science style approaches, is we can't just rely on a single model using a single feature set. We have to look at the results that we get when we look at a different data source or a different feature, or we apply a different model. And so we're working now at looking at what we see in the overlap in the various stages of my approach with what Entra's first-party model turns up, especially when they lower the threshold as well and they generate more results. And the good news is, for people who maybe aren't benefiting from Microsoft's internal detection that I built, is this, of course, will become part of Entra's first-party detection itself. So it won't just be something that lives kind of internally for us. It's something that's going to get rolled up into that product as well. And now I'm down to about 2 results per month, and Chris is not going to fire me, so that's good. So I know there's someone in here who's been waiting all day to see an architecture diagram. So friend, don't worry, I got you. Here's one. For any of you who are interested in kind of how we actually do these sorts of things, like how we build these AI and ML models and use them to generate detections, then I make Chris go investigate. This gives you a high-level view of that. So we're taking in data from Sentinel, but also taking a lot of data that we're just storing generically in the data lake, and then we're sending that to our computing environment of choice, which is Synapse. It's really similar to Databricks, if anyone is using that. But more generically, it's just an environment for me to create notebooks. And so I have these PySpark-powered notebooks. I have a pipeline that gets triggered every day, so it does all of this work. And then it takes all of those results, writes them out to both a Custo cluster, because that's where Chris and his team want to look at the data. And then for my purposes, also writes it out to the data lake so that I can do more analysis on the results and trends of what we're seeing over time as well. And so we've had a ton of content here, and I don't want you to forget everything. So just in case, going to leave you with a few final points. The first is, when you're thinking about these service principles, conditional access is still going to be your friend. It may not come in that same traditional form that you're used to seeing when you're thinking about how you used to manage your user accounts. But these non-person accounts can be extremely attractive targets for threat actors in your network. So the easiest way to minimize the potential damage when they get popped is to have put in place the right guardrails and the right controls so that you don't have some enormous blast radius that you have to worry about. Second thing we'll say is the data is out there for those of you that are going to try and take this home and do your own investigation, look for your own anomalous behavior. So there's tons of different log sources available. They're going to capture lots of different things, like what's going on with your permissions, but also what activities are you seeing from these types of accounts. So it's there, you can find it. And the last thing I'll say is, don't worry, no good machine learning ever goes unused here at Microsoft. So even though I built this really cool custom thing for us internally, that's not how it's going to stay. I think of the role of my team as to only build short-lived things, because they either don't work, so we kill them, or they do work, and therefore they belong in a product, and I want every Microsoft customer to be able to take advantage of that as well. So that's all we have for you today. Thanks for coming to listen to the talk. And you can find us in the Blue Team Village after if you have any questions or want to talk about anything further.